Probably the most well-known network layer protocol is, of course, IP, or Internet Protocol. As I mentioned in the beginning of the course, the Internet Protocol, or IP, is responsible for addressing hosts, encapsulating data into packets, or datagrams, including fragmentation and reassembly, and routing packets from a source host to a destination host across one or more IP networks. So like other Layer 3 protocols, IP is connectionless, which means it doesn't care whether the packet has reached the destination or not. That's what Layer 4 is for. All right? So there are two versions of IP that currently coexist within the global internet: IP version 4, or IPv4, and IP version 6, or IPv6. IP addresses are made up of binary values and drive the routing of all data over the internet. IPv4 addresses are 32 bits long, and IPv6 addresses are 128 bits long. Right now we're going to see each of the versions in detail. But before we move on, let's compare the main features of each version. IPv4 is a 32-bit address, and IPv6 is a 128-bit address. Now, theoretically, you can address 2 to the power of 32 devices in IPv4, which is about 4.3 billion, right? In IPv6, on the other hand, you can address 2 to the power of 128 devices, which is, well, let's see. Why don't you just do the math on your own? So IPv4 is represented by the decimal equivalent of 4 octets, separated by dots. The biggest number one can make with 8 binary digits is 2 to the power of 8 minus 1, which means 255. So each octet can be any number from 0 to 255, right? Now, 128-bit IPv6 addresses are written using hexadecimal, as opposed to dotted decimal in IPv4. So because a hexadecimal number uses 4 bits, this means that an IPv6 address consists of 32 hexadecimal numbers. These numbers are grouped in 4s, giving 8 groups or blocks. The groups are written with a colon as a separator.